Now looking at function notation, I'm going to show you how we can blend doing it by hand with getting reinforcement and confirmation from the graphics calculator. So I'm just going to look at exercise 3B, the example on page 67 of the Hazy textbook. And you'll see that they've got fx equals 2x plus 3. Now, we can't do fx on these calculators, but y1 is our sort of equivalent to 2x. And if we go graph, we can see the lines here. The window's not perfect, so if I go zoom standard, which will give me a minus 10 to 10 window in both axes, then we can see that there's the straight line, just like in the example. We can equally find the value, so it does ask us for the value when x is 2. So we can go second calc value, and you see down the bottom when x is 2, we can get the answer, which is 7. Gives us a nice marker there too. We can also go into table and scroll up and find out what it was at 2. Equally, you can find out what it was at minus 4, which is the other question that it asks us. So that's several ways of doing it, but I think it's quite nice as well. Think about that function notation. To do it this way is a similar syntax as the function notation. We can get the y1, which is our equation up in here, using alpha f4 as a quick key to find it. And if we do brackets and then type the number in, let's say we're going to do x as 2. So it's a bit like the function notation. It's like fx or f2. We can see that it'll also give us the answers that we want. We could arrow up, copy that again, and change it to -4. And we can see it will give us the other answer that we wanted. And probably the last thing is obviously when it's trying to find us when y is a certain value, say y equals 5. The simplest way to do that is to put a line in at 5, so y equals 5. When we graph that, then they'll intersect, and then we can calculate where they do intersect. Press the 2 enters, and then a third enter will give us where they intersect. So when y is 5, x is 1. Hope you found that useful. Thanks for watching.